Hey, grade eights, I'm back. Um, so we are on section 10.3 in your textbook. Always good to go look at some of the examples there as well, if you're wanting to understand this stuff. So this is now the first time that we are actually doing something that was not covered in grade 7, and that is looking at solving equations in this format here. So x divided by a plus b is equal to c. And then it could be minus b as well. There could be negatives in there. So we didn't do that in grade 7. It's very quite similar. We might have done some practice ones, but it technically wasn't part of the curriculum. Um, so it's pretty similar to what we were doing last, and I'm just going to get into some examples to show. So let's show these ones just by modeling. So you won't often have to do the modeling, but it does give us a good sense. So remember, so if we have x divided by 4, it doesn't meet, minus 5 is equal to negative 7. This is the same thing. The equal sign means it's like a teeter-totter that has these things on both sides. Now, x divided by 4 would really mean if we had, like, let's say this strip that was what x is equal to, we only have 1/4 of that filled in. So that's x. If this whole strip here is x, divided by 4 shows us just that quarter of it. Okay? So this is x. On this left side of the equal sign, left side of the teeter-totter, we also have minus 5, which is the same as 5 negatives. So I could show 5 negative integer chips to show that we have that there. And then on the other side, we have 7 negatives. 1, 2, 3, 4, 5, 6, 7. Okay? So I want to figure out in these questions, all these questions when we're solving them, we're trying to find what one of those variables is equal to. Okay, so get just x, one whole x, on one side, and then what that's equal to on the other side. So to do that, the first thing I'd have to do is get rid of these 5 negatives that are with my x divided by 4, because I want to get the x all by itself. So if I get rid of those 5 negatives, I would essentially do that. You know, if I did have those 5 negatives, how do we get rid of negative integer chips? Well, we put in positive integer chips, and each one of those makes a 0 pair, right? Those all cancel out because they make 0 pairs. So that's like we're adding 5 here. Okay, so it was minus 5, I add 5, that cancels out to be 0. To keep it balanced on both sides, I also have to add 5 integer chips on this side, 3, 4, 5, which cancels out with 1 negative each one because they're all 0 pairs. So when I add 5 on this side, all that I had left here was 2 negative integer chips. So everything else gets canceled out. Well, all I have left is the 2 negative integer chips. All of these got canceled out. Okay, so now I have that x divided by 4 is, or 1/4 of x is equal to 2 negatives, or negative 2. So how much would 1 whole x be equal to? Well, if I were to fill in another section, that would be another 2 negatives. To fill in another section, that would be another 2 negatives. To fill in another section, that would be another 2 negatives. Really, what I did, since I only had 1/4 of them, and I want to get a whole amount, I multiplied it by 4, and I multiplied by 4 on the right side as well. Okay? And then that left me, now that I have 1 full x here, a totally filled in one, how much do I have on the right side? I have 8 negatives, so I'm saying that x is equal to negative 8. Okay, well, is that true? Well, we can do a check. It's very important to do these checks. And I'm going to take negative 8, I'm going to put it into my equation. So I said x is equal to -8, so I'm going to place that for x, so -8 divided by 4 minus 5 is equal to negative 7. So now that I'm not solving for x, I need to follow order of operations. So I do the division here first. So negative 8 divided by positive 4. A negative and a positive makes a negative. So I have negative 2 minus 5 is equal to negative 7. Negative 2 minus 5 from negative 2 is negative 7. So negative 7 is equal to negative 7. Therefore, my left side equals my right side. Therefore, negative 8 must be the right solution for that. Okay? Maybe a little bit confusing, but hopefully you're sort of getting that. Okay, let's look at b here. B is negative p divided by 3 plus 1 is equal to negative 4. Okay, so let's model it quickly. I have my teeter-totter. So my p is divided by 3, and it's a negative. So it's sort of hard to show this in diagrams. But if this is negative p, if this whole thing is equal to negative p, I only have 1/3 of it. 1/3 of that negative p. Okay, I also have one positive, so I'll do a positive integer chip, which is filled in. And then on the right side, I have 4 negatives, so 4 negative integer chips that are not filled in. So I want to get rid of this one positive integer chip on my left side, because I want to get just p on the left side. So if I add in a negative integer chip, that cancels them out. But to keep my teeter-totter balanced, I also have to add a negative integer chip here. In my equation, it's like I'm subtracting 1 and subtracting 1. The 1's cancel out. Negative 4 minus 1 is negative 5. Okay, so now I'm left with negative p divided by 3, or 1/3 of negative p, is equal to 5 negatives. Well, if that's 1/3, if I times this by 3, it's going to get totally fill. I'll have 3 times as much. So now instead of having 1, I'll have 3/3. So if I times this by 3, I'm going to have 5 of them. Times by 3 is 15. That's 9, 10, 11, 12, 13, 14, 15. Okay? So now I have negative p is equal to negative 15. Okay, so what is just p equal to? Well, p is the opposite of negative p, and so the answer would be the opposite, which would be positive 15. Another way you can think of it is whenever you just have just one variable, there is actually a 1 in front. So this is actually negative 1p is equal to negative 15. If I want to get rid of that negative 1, I can divide it by negative 1, divide the right side by negative 1. Let me scroll down here. Now the negatives 1's cancel out here, so I'm left with just p, and negative 15 divided by negative 1 is equal to positive 15. So the answer is positive 15. Can I substitute back that into my original equation, positive 15 and for p, and get the right answer? Let's see. So remember, p is equal to positive 15. I still have this negative sign up front. So it's still, I still have to write in negative p. P is 15. So it's negative 15 divided by 3. You can't forget that negative. Even though p is equal to positive, there's still this negative symbol in our equation. Negative 15 divided by 3 plus 1 is equal to negative 4. So negative 15 divided by 3 is equal to negative 5. Plus 1 equals negative 4. Well, hey, great. Negative 5 plus 1 is negative 4. Since the left side equals the right side, I must have the right solution of p is equal to positive 15. Okay, so that's with diagrams. Maybe that helps some of you. If not, you don't need to really use them. But you just need to follow this reverse order of operations. When you're solving for a variable, you do the opposite order of operations. So for a, let's go through these. We have negative x divided by 12 minus 6 is equal to 4. Okay, so first thing I need to do is not the multiplication or division, but get rid of the addition subtraction since I'm undoing it. So x is having 6 subtracted from it. I'm going to add 6, do the opposite on both sides to keep my equation balanced. The 6's cancel out. On my left side, all I'm left with is negative x divided by 12. And that is equal to 10. 4 plus 6 is 10. I can now want to get this x all by itself. It's being divided by 12, so I'm going to multiply it by 12 and multiply this side by 12. So do the same thing to both sides, which is the opposite of what was being done to x. So the 12 times by x, the x divided by 12, that cancels out because 12 divided by 12 is 1. And I'm left with negative x is equal to 10 times 12 is 120. So if negative x is equal to 120, then actually just x without that negative would be equal to negative 120. Okay, so we can put this into our original equation to check if this is right. Because it's like, well, hey, maybe I made a mistake somewhere. So it's really important to check. So our initial equation, I'm going to take this and I'm going to put negative 120 in for x. So remember, it was negative x divided by 100 or divided by 12. Yeah. Minus 6 is equal to 4. Okay? So this is the initial one. So I have to take negative 120, which is what x is equal to, and I have to put that in for x. But remember, there's this negative sign here. So when I put that in for x, I'm actually going to have negative 120. Okay? So x is negative 120. There is this negative sign that is actually just part of the equation that isn't part of my solution. And that can be confusing sometimes, and people make a mistake there, is where they see they get x has a negative, and then they see that there's this negative sign in the equation, and they think, oh, that's the same thing. It's not. It's actually negative 120, which, if you have negative 1, right, remember that negative in front of a variable actually means negative 1 times by that variable. If you have negative 1 times by negative 120, that now turns into positive 120. Okay, so I have positive 120 divided by 12 minus 6 is equal to 4. So when I kept this negative in what my variable is equal to, it actually ended up canceling out that other negative, so it's a positive on top. Whereas if it had remained negative, it wouldn't have worked for my solution. So 120 divided by 12 is equal to 10. So 10 minus 6 is equal to 4. 10 minus 6 is 4. 4 is equal to 4. Great. I must have put in the right number of negative 120 as my solution for x. Okay? Let's do the next example, b here. So b is negative 4 is equal to 3 plus k divided by 7. Okay, first thing I need to do is get rid of the whatever's being added or subtracted to k. So this is 3 plus k. This 3 is positive, so I'm going to subtract 3, put in a negative 3 to cancel it out, and do a subtract 3 or negative 3 on the left side. And now I rewrite. Negative 4 minus 3 is negative 7 is equal to, on the right side now, this is a positive, so I don't really need to write that because it's just saying that that fraction is positive. K divided by 7. Okay, k is being divided by 7. I'm going to do the opposite and multiply k by 7, which cancels them out. I have to do that on the other side as well, multiply by 7. So I get 7 times by negative 7. So 7 times 7 is 49. A positive and a negative makes a negative. So negative 49 is equal to k. That is my solution. Let's put negative 49 back in for k. So initially was negative 4 is equal to 3 plus k divided by 7. So I'm going to put this 49 in for k. So I substitute that in. I get negative 49 So now I'm having to solve the right side to see if it's equal to the left side, which means I need to follow regular order of operations. So I first do negative 49 divided by 7, which gives me 3 plus 49 divided by 7 is 7, negative and positive. 3 plus negative 7. Okay, so if I have negative 4 on the left side, 3 plus negative 7, or if I have positive 3 and 7 negatives, in the end, that's like I'm subtracting 7. It brings me down to negative 4. Since the left side is equal to the right side, that means that my solution is correct. Okay. Hopefully that makes sense. It is a little bit trickier than what we were doing before, but again, you're just following the same steps. Whatever's being done to x, you need to do the opposite on each side. Okay, I just want to look at some interesting cases that you will not really see much of in the textbook or on the test or anything, yet they do sort of fall into this type of algebra that we're looking at right now. So here I have 4 minus x over 5 is equal to 11. So the first thing I need to do is get rid of this 4 because I want to get x all by itself. Now what some people do, since they see this negative symbol or subtraction symbol behind it, is they say, oh, well, since it's 4 minus that, I go plus 4 to cancel it out. But that doesn't work because this is a positive 4. That's not a negative 4. And if you just added 4 to 4, you would be left with 8. So they wouldn't cancel each other out. You need to get rid of them. So I'm going to subtract 4 because that's a positive 4. So I subtract 4 on both sides. These 4's cancel out. Now when I rewrite, I haven't gotten rid of this negative symbol. So that negative symbol, even though it was a subtraction symbol, it now sort of just becomes a negative symbol. That has to remain there. Okay, and so that's going to become negative x over 5. That has to stay there, is equal to 11 minus 4 is equal to 7. Thanks. So we have negative x divided by 5. Now this negative symbol is saying that sort of this whole fraction is negative, but we could apply that negative symbol to either one. Okay, so I could say it's actually x divided by negative 5, because that would give me a negative answer as the total, or I could say negative x divided by 5, because that would give me a negative answer of a fraction. So when there's a negative in front of a whole fraction, you can actually just sort of choose whether you want the x to be negative or the 5 to be negative. So I'm going to choose that the 5 is negative, and now I can multiply by negative 5, multiply the x by negative 5, and multiply this side by negative 5. The negative 5's cancel out over here. I'm just left with x is equal to 7 times 5 is negative 35. Okay, does that make sense? 4 minus negative 35. So if I replace this x, let's check my answer. Because did I get it right? I'm pretty sure I did, but let's double check. So 4 minus x is equal to negative 35. So I have to put in that negative 35 into my, where I place x, divided by 5 is equal to 11. So negative 35 divided by 5. I have to follow order of operations now, so I'm doing the division first. So it's going to be 4 minus negative 35 divided by 5 is going to be a negative 7 is equal to 11. Well, 4 minus negative 7, taking away negative is the same as adding a positive, so that's the same as 4 plus, because I can keep, change. 4 plus positive 7 is equal to 11. Well, 4 plus 7 is 11, so 11 is equal to 11. So the answer is x is equal to negative 35. Okay, that's a really tricky one. Sorry if that was confusing. You're not really going to see this, but I just thought I'd put it out there just in case you do on Mathletics or wherever else. It can happen. Here's another case, and in this one, the x is on the bottom. Okay, but first steps first, I need to get rid of the addition or subtraction. So I'm going to add 6 on this side. I'm going to add 6 on this side. The 6's cancel out. I'm left with 16 divided by x on my left side. And on the right side now becomes positive 4. Okay? Now some of you could probably just solve by this by inspection. Well, 16 divided by what equals 4? Well, many of you may know that already. But let's go through as if... Okay, we're back. Sorry, Smart Notebook stopped responding there. I hope the video works out. We might have to skip a little bit if it was just still there. I don't know. Anyways, so we were saying if we needed to get the x all by itself, I can't just multiply by 16 because 16 times by 16 doesn't cancel it out. 16 times by 16 is, I don't know, some big number. So what I'm actually going to do is I'm going to multiply by x on both sides. Multiply by x on both sides. So the x's on the left side cancel out. I'm left with 16. And then that's equal to 4 times x is 4x. Now that the x is not the denominator, so we'd never really want it on the bottom of a fraction, so you can always multiply it by itself on both sides to get it back up top. Now I can divide by 4 and divide by 4, and now I see 16 divided by 4 is 4, so 4 is equal to x. Which is true. We can check just 16 divided by, if x was 4, 16 divided by 4 is 4, minus 6, yes, that's equal to negative 32. Okay, so just a few more, slightly more complicated scenarios with these two. Again, you won't see it too much. We went through the same steps. We just got rid of the addition or subtraction, and then we just canceled out whatever else was in the fraction with x. Okay, let's just look at a word problem and how we can solve these. So the cost of a t-shirt, so a t-shirt represented by t, is, so whenever you see the word is in a word problem, that's meaning saying that something is something, so is equal to. We could say, if you were able to say in the sentence instead of just is equal to, you could probably put it an equal sign. So the cost of a t-shirt represented by t is equal to $3 more than half of the cost of a pair of jeans. A little bit confusing, but $3 more means that we're adding $3 to something, and then it's $3 more than half the cost of a pair of jeans. So the cost of a pair of jeans divided by 2 would be half of that cost, plus 3. Okay, so this is that first sentence here. The cost of a t-shirt is $3 more than half the cost of a pair of jeans. I have this in my equation now. The cost of a t-shirt is half the price of a pair of jeans, jeans divided by 2, plus $3. So $3 more than half the cost of a pair of jeans. Okay, so I just checked that my equation that I wrote matches that sentence, and it does. So I'm on the right track. It's an equation that I'll be able to solve. My second sentence, I'm told a t-shirt costs $18. So I can substitute the t, I can get rid of my t and substitute in 18. Because a t-shirt is $18. Now the question is, how much does a pair of jeans cost? So we are needing to solve for j. So write out an equation, we already did, that describes the situation, and now we can solve for j, the cost of a pair of jeans. So if I want to find j, the cost of the pair of jeans, I first need to get rid of this 3. So I'm going to subtract $3. Subtract $3. And this is going to tell me what just half the cost of a pair of jeans is. So 18 minus 3 is $15, is equal to a pair of jeans divided by 2, or half the cost of a pair of jeans. To get just the j, since it's being divided by 2, I multiply by 2. Multiply by 2 on both sides. The 2's cancel out here. 2 times 15 is $30, is equal to a pair of jeans. Sounds reasonable. Let's look at my situation here. I said a t-shirt was $18. We said that was $3 more than half the cost of a pair of jeans. Well, half the cost of a pair of jeans, if it's $30, would be $15. $3 more than that is $18. So it sounds like my situation works out. Okay, so do the work in the textbook. Maybe check out some of the examples there. It may be fairly helpful. And then do that work and then the Google quiz. And that is it. See you later, grade 8s.